All right, let's get to it. This is question 3 from the Chapter 6 review. I believe we did this in class, but here's a request anyways. How do you solve this with a calculator? Well, I see that every single value here is some multiple of 7 and some multiple of 2, so I think we can somehow make this work using exponent laws. Consider this. Log 2, if I were to multiply this out, I can get 256. Which I know is actually 2 to the power of, let's say, 2, 4, 8, 16, 30, 32, 64, 130, to the power of 8. Let's say you didn't like that. You didn't like that. You could also split this up and say this is log 2 of 8 plus log 2 of 32 using product law. Anyways, let's pretend you're just going to multiply it out. This is log 7 of, this is, oh, let's see, 7 to the power. You know what? Yeah, I don't like this. I'm going to encourage you to try to change everything into a base of 2 because it will make your life a little bit easier. 8 is 2 to the power of 3 multiplied by 3 is 2 to the power of 5. Log 7. This is 7 to the power of 2 times 7 to the power of 1 over 4. Let's simplify it. Log base 2, 2 to the power of 8, and log 7, 7 to the power of 2 plus 1 over 4 is 9 over 4. 9 over 4. Using the power law, the exponent drops down as a regular coefficient, and the exponent drops down as a regular coefficient. We have ourselves 8 times 1, 9 over 4 times 1. So the final answer is 3241 over 4, or 10.25, of course. That's it. As you can see, when I started this question, I stuttered, and I approached it in a variety of different ways. If you didn't do it this way, that's okay. There's literally a gazillion different ways you can try. For example, I mentioned before that you could try using product law. This is log 2 of 8 plus log 2 of 32, which is added to log 7 of 49 plus log 7 of 4th root of 7, which is 7 to the power of 1 over 4. That becomes a 3. This becomes a 5. That's a 2. This is 1 over 4. And you get the same answer. Hope that helps. Moving on to the next question. The next question that was asked was, uh, let's see, log 2 of log 3k equals 2, right? We also did this in class, I think. If I have log 2 of log 3 of k, then that equals a 2. What is k? Um, there's no real trick to it, really. Seeing as how we have a log of a log and all the bases and the actual exponent and everything is given, we can convert this into its reciprocal function. If you're confused of how this works, why not substitute this and let's put in the letter x, okay? If I had log 2 of x equals 2, well, can you rewrite this as an exponent? It should be if the base is a 2 and my exponent is a 2, that is the answer, which of course you know is 4. But remember, that x isn't just x, it's actually substituting log 3 of k. And you do the same thing. If the exponent is a 3, sorry, if the base is a 3 and the exponent happens to be a 4, this will be my answer. So the value of k is actually 3 times 3 times 3 times 3, k equals 81. That's the final answer. The last question is number 10. 2x plus 1, 8, 2x. 2x plus 1 equals 8, 2x. Now I didn't do this specifically because This was easily done using what we learned recently in chapter 7.1. So it sort of spills over into the next chapter. So I didn't really talk much about it. But if you are curious, the best way to handle an equation such as this is make the basis equal. But let's pretend this is chapter 6 and you didn't know that. What you could do is change both of these or log both sides. And remember, if 2 to the power of x plus 1 is the same as 8 to the power of 2x, then logging both sides should also give you the same answers. From here, the exponents will drop down, leaving me with a log of 2, which I can use a calculator to solve. The exponent drops down, log 8, which you can use a calculator to solve. So if I do that, I actually don't know what that number is. Let's do it really quickly. Log of 2. So this becomes approximately 0.3 x plus 1, and log of 8 is approximately 0.9 times 2x. So distributive property, 0.3x plus 0.3 equals, 1.8x. Group-like terms together, 0.3 equals 1.5x, and x will therefore be approximately 0.2. And that's it. Hope that's useful. Continue working hard and keep me posted.